Hello, everyone. Hope you all are doing great and welcome to the pre hackathon speaker session. Those who are joining for the very first time, let me tell you the Python week will be hosting live workshops, talks, discussions, and of course, an amazing hackathon is there on starting from 8th of January and we land on 10th of January. It is a 48 hours of hackathon, and make sure to register from our website. The hosting of this live workshops talks and already has been started from 1st of January, so be sure to see the recordings. So now moving on to the today's speaker session, the workshop is going to give an introduction to the Tezos blockchain and how one can start developing decentralized application on top of Tezos using the SmartPy smart contract language. And with that being said, let me introduce you all to our today's speaker. We have Shomu joining us. Hi.
Hey, hi Tirthak. Thank you
So,
for having me.
yeah, let me introduce you to all of our participants joining us today. So, he's a final year CS undergraduate student and a backend developer with a keen interest in decentralized application and blockchain. He has worked mainly on the Ethereum Tezos blockchain and is currently working as a blockchain intern in Tezos India Foundation. We welcome you, Shomo, and looking forward to your talk, decentralizing the stage to you.
Thank you so much. Thank you so much. Okay, so let's start then. Um, Hopefully my screen is visible to everyone. Awesome. So yeah, so today the talk is about getting started with Tezos blockchain on Python. Okay, so I'll give you a brief overview of the whole session. So we'll start with a brief introduction to blockchain and what blockchain is, the features of blockchain and why you should be developing on blockchain. Then we'll move on to Tezos, the blockchain that we'll be working on today. And we'll be talking about some unique features of Tezos specifically. And then finally, we'll have a hands-on session on writing decentralized applications using SmartPy and Python, obviously, on Tezos. And we'll be deploying it and we'll be able to interact with it directly. So let's start. Okay, so what is a blockchain, right? If you search for the term blockchain on the internet, you will find a very common definition like this: a decentralized distributed ledger. So yeah, there's a lot of buzzwords there: decentralized, distributed, right? So let's break it down and understand what it is. So, so let's start with the word ledger. So ledger, if you're, I believe all of you know, is basically a log of transactions, right? You have seen your local businesses and shops basically keeping a logbook of all the transactions that happen in a day-to-day business, right? So they use that to calculate the expenses and expenditures and profits and those things. So similar to that, the whole blockchain is basically a complete ledger, a logbook of these transactions. So these transactions are basically the transactions that you do on that network itself. So let's say I'm on you must have heard of popular blockchain networks like Bitcoin, Ethereum. So these are all popular blockchain networks and cryptocurrencies. Basically, Bitcoin is skyrocketing right now. So yeah, so I think it's everyone has some idea about Bitcoin, right? So let's talk about Bitcoin itself then. So let's say I'm sending someone, let's say I'm a person A, 10 Bitcoins. That is too much, but let's say just for example. So I'm sending 10 Bitcoins to that person, and that transaction, right, like me sending 10 Bitcoins to a person named A, is actually recorded in that blockchain. So the transaction is like persisted in the blockchain itself. So that makes the blockchain a basic ledger altogether. But that is not the main feature of blockchain altogether, right? So if we move on, um, distributed and decentralized, right? So these are the main features you can think of. So what does distributed mean, right? Blockchain, unlike our own centralized, client server systems, is not actually stored in a single server or system, right? So this ledger that we are talking about, right, this blockchain, the log of all transactions, is not stored in a single particular system or server, but rather it is distributed among multiple nodes or systems that are connected to that network. So it's basically a P2P or peer-to-peer network, right? So each node is a peer, and each node itself has this blockchain, the data of the blockchain, the ledger, complete ledger. So that makes us distributed basically, and decentralized in the sense as um, so in our physical world, right? When we do a transaction, it's mostly via a middleman, right? Either it's a governing body or a bank or something like that, right? So if I send you some, let's say, some money, right? I'll always be going to a bank or something like that and doing the transaction via that bank, right? But in blockchain, there is no central body, like central middleman or trust body that handles these things, right? So all the transactions actually go through in a decentralized manner. So basically, no one will actually be able to control your transactions, and that actually provides a lot of power to the whole blockchain network or system, basically. As you can see in the diagram, right? In this diagram, we have a basic representation of a blockchain, right? So each block here, so these boxes are the blocks that are in the blockchain, and it forms a chain. Like if you have studied linked lists in your course, maybe in your syllabus, if you're a computer science student, then you must have studied linked list, right? So it's basically kind of like a linked list. So each block is linked with the previous block. Like the link is not visible here, but there's a link right here. It goes from here and then there. So the hash of the previous block is stored in the current block, and also the hash of the current block is also stored. So that way it connects the whole list of chain of blocks together. So that is how a blockchain looks like, and basically it is, right? So moving on to the next one. Let me share the screen again. Yeah. So moving on to the next one. So why blockchain, right? Yeah. So why blockchain? So as I said, blockchain is a decentralized system, right? That means there is no central authority, right? All your transactions happen in a decentralized manner, basically. So what are the benefits of having this feature, right? So let's say in case of a bank, right? Today we trust a bank, and we trust that the bank will be unbiased towards any of the parties, and it will give a unbiased judgment to the transaction, right? But let's say in the future it can happen that the bank gets corrupted or something like that, right? The middleman gets corrupted. So that what that can happen, what that will do is basically it will basically fail the whole transaction, right? It will have a drastic effects on the transaction itself, and it's not suitable. But in a decentralized system, when there is no such middleman or trust body, you don't actually have to trust anybody to do these kind of transactions, right? So in a blockchain, how this decentralization is achieved is through consensus. So consensus is basically like taking the opinion from each of the parties that are participating in the network, basically each of the nodes that are there in the network, and then deciding whether, like, taking the decisions from these parties and then getting an average of the decision, kind of like that, right? So that is like a consensus between all these parties. Different blockchains implement different consensus mechanisms. Bitcoin and Ethereum 1.0 followed the proof of work consensus algorithm, and the Ethereum 2.0 and Tezos follows the proof of stake algorithm, basically. So that is how decentralization is a crucial part. Then comes immutability, right? So I did not talk about this one in the previous slide, but what blockchain provides is also is like no one can ever change your data, right? So let's say in a normal centralized server, right? If someone has access to the database, then they can change your the data that you have put in, right? So let's say in a bank server, right? If someone gets access to the bank server, they can basically change the balances of different accounts and do different things with that transactions and those things, right? But in a blockchain, this is not allowed. Basically, the data that you put in the blockchain is permanently stored in the same state forever. And with that, we also have no censorship and public data. Like the data in the blockchain is completely public, right? So as I said, like no one has access to the data that you are storing in the blockchain. So no one has access, as in like write access to the data. Everyone can read the data and verify the data, but they cannot write or update the data that you have put into the blockchain. So that ensures that there's no censorship. Like for example, in case of Twitter, right? Twitter does a good job with censorship, but let's say Twitter goes, you know, in a different direction and starts censoring whatever posts you do on or tweets you do on Twitter, right? And basically, it's violating your freedom of speech, right? But on a blockchain network, it's not possible because no one can, delete your data or change the data basically, and that's how no censorship comes into play. And similarly, trust. Uh, Blockchain is trustless, right? So you don't actually have to trust anybody to actually transact with them on a blockchain network, right? Because like there's a consensus mechanism out there that will, and the immutability feature, right, that will make sure that uh, the data, the transactions that happen on the blockchain are always verifiable and are always as it is, right? It's immutable, right? So you don't need to trust anybody to actually be part of the blockchain or like transact through a blockchain, right? So these are the main features of what blockchain provides. There are other features also, but I think these are the most crucial ones. So moving on to decentralized applications, right? So as developers, we are interested in on building things, right? Building applications, building products, basically. So blockchain, what we can do is like we can leverage the features of blockchain, right? The features like decentralization, immutability, and no censorship, and these features, and build applications on top of it. So decentralized applications are basically the applications that are running and are actually existing in the blockchain itself. So these nodes, right? Nodes in the blockchain are actually running this applications, and basically these application itself embody the complete feature, like all the features of the blockchain itself. So any application that you run in a decentralized manner, like any decentralized application that you're running, will also have the features of the blockchain itself. So some examples of decentralized applications that you can find right now are games, decentralized games like CryptoKitties, and then we have DeFi, that is decentralized finance. So it's a pretty hot topic right now. So you have popular DeFi platforms on Ethereum and also on Tezos. We are having more and more platforms on Tezos also. So DeFi is also a pretty big implementation of a decentralized application. And then we have collectibles, right? Like NFTs. If you have heard of NFTs, basically these are like digital assets that you can collect. So you can think of collectibles as in games like, let's say, CS:GO or Fortnite. If you have played them, you'll find they provide you skins and guns and those things, right? So these things can be converted into blockchain collectibles, basically blockchain assets called NFTs, and that way blockchains can be integrated into these live systems too. Okay, so moving on to the next slide. So how do we write, right? How do we write these decentralized applications? So to write a decentralized application on a blockchain, what we do is we write smart contracts, right? So smart contract is basically a script that is your code stored on the blockchain that enables users to define some custom rules and protocols for various purposes. So some typical examples include escrow accounts, insurance contracts, decentralized applications that we're talking about, DeFi applications, anything, tokens and those things, right? So that is possible with smart contracts. If you want to visualize smart contracts, then you can think of smart contracts as something similar to serverless code. Like they're very different, but in sense, like you write just the functionality. You don't write the code to run a server or handle the networking and those things. You just write the code for your functionality that you need, and you deploy it in the blockchain. And whenever you need to interact, you just call these functions. Just something similar to how serverless functions work, right? You write your function and you deploy it on AWS or something like that, AWS Lambda or something, and you can just call these functions directly. So something similar is can be done with smart contracts. Okay, so I think we have covered a pretty good amount of details on blockchain and decentralized application. So now we can move on to the actual part, that is Tezos. So today we are discussing Tezos. So Tezos is a self-amending cryptographic ledger, as mentioned here. So Tezos is a cryptocurrency. The it's the cryptocurrency. The what do you call it? The abbreviation or the term for the cryptocurrency that Tezos provides is TZ or Tez. You can pronounce it as whatever you want. The symbol for the currency is XTZ, as you can see, and it basically provides all the features of a blockchain, that is borderless transaction capabilities and also smart contract capabilities, right? So okay, so we also need to know that not all blockchains support smart contract features and not all blockchains support cryptocurrency features, right? So for example, Bitcoin does not support smart contracts, it only provides a cryptocurrency. Ethereum and Tezos, on the other hand, provide both. And blockchain like Hyperledger. Like Hyperledger is a blockchain technology that does not provide the cryptocurrency feature, but provides you features or capabilities of building decentralized applications, something similar to smart contracts, right? So yeah, so Tezos is a blockchain protocol, or basically a network that supports both cryptocurrencies and smart contracts. Uh, so in Tezos, we have programmable money. That is your smart contracts. Basically, you can program the smart contracts to accept and to send uh, Tez, basically the amount or the funds that you have. And it's basically the main feature of Tezos is that it has a self-amending capability, but that is in a normal blockchain, what happens is you will in case of Ethereum specifically, right? Let's say, so when there's a upgrade to the network, right? So there's a chance that there will be a hard fork of the network altogether. So hard forks are basically like the chain that is there, the Ethereum chain blockchain is copied over and it's split into two. So there are two versions of the Ethereum blockchain at that time, right? When there's a hard fork, so that can cause a lot of problems in situations like DeFi and those things, right? Because you have to support the DeFi platforms will have to support now both these chains, and there are discrepancies between the chains, and those things can happen, right? But with Tezos, there is no such complexity of hard forks, because the chain itself, the network, the protocol itself can be upgraded through an on-chain governance process. So basically, all the community votes for the particular protocol or the particular feature to be added or not. And if there's enough vote and enough support for the particular change, the protocol or the software that's running the software, as in the system that is running the Tezos protocol, basically will upgrade to that particular feature, right? So that's how on-chain governance is done in Tezos. And in Tezos, we also have something called liquid proof of stake, right? So we were talking about the consensus algorithm at the beginning. Bitcoin and Ethereum 1.0 supports proof of work, right? So let's talk about the consensus algorithm a little, then we'll understand this proof of stake a little bit better. So proof of work is basically like in a blockchain network, what happens is you send a transaction, right? And these transactions need to be included in a block, right? So what happens, there are nodes in the network that actually create these blocks. In Ethereum 1.0 and Bitcoin, they're called miners. So basically, these miners are the ones that are creating these blocks, so including your transactions in the blocks and creating these blocks and adding them to the chain, basically. So that is what a miner's job is. And to verify the work done, so basically to verify whether a block is valid or not, what happens is the miner to actually produce the block, sorry, to actually produce the block, the miner has to actually solve a cryptographic puzzle, basically. So it is like you have to do some computational work on top of that puzzle, and then you have to solve it, and you have to put the solution in the block itself. So this solution is basically the proof of work done by the miner. So this is how these Bitcoin and Ethereum 1.0 function. So basically, the other nodes that are there in the network, will basically validate this block, right? That is how decentralization happens, right? Other nodes are giving a consensus of the consensus on the validity of the block, basically. So they are going to validate the block, and they're going to look at the proof of work that is provided by the miner. And if all the conditions are valid, like all the conditions are true, and only then will the block be accepted by the other nodes. So that is how proof of work works. So in case of proof of stake, what happens is, these miners or the block creators are not going to actually solve a cryptographic problem, but rather what they're going to do is they're going to stake or lock up some of their funds. So in case of Tezos, these miners who are staking are called bakers, basically. So bakers are those people who will lock up their funds, that is, lock up their Tez, and for some specific period of time, maybe, and that would allow them to basically mine or bake, in case of Tezos, to bake these blocks, right? And the other bakers that are there, right, they will basically validate the block, and they'll check whether that the block that has been created is valid or not. And also they'll check the proof of stake, that whether the baker has stake in it or not, has provided the stake or not. And if the blocks have some discrepancy or some double baking or something like that happens, then the stake that the baker has put out, right, has locked up, will be deducted. So basically a penalty will be imposed on the baker. So that is how proof of stake works. And by liquid proof of stake, it means that in Tezos, what happens, like, we have bakers, and then we have just normal users, like, people just holding Tezos, right? The holding the Tez, the cryptocurrency, basically. So what these normal people can do is, like, they can basically delegate their funds to someone, and that will allow that person, that baker, basically. So the users are delegating their funds to the baker, and the baker can then now use that fund in their stake, right? So that way, basically, the normal users can also get some rewards out of the baking process. So after each block is created, some reward is provided to the baker, right? So that is for the participation in the network. So they'll get some reward in the cryptocurrency of the network. So that is delegation in case of Tezos. But unlike other networks, like some networks, what happens is delegation is if you delegate to someone, the funds that you've delegated will be locked up for a specific period of time. But in case of Tezos, it is not the case. The delegators can basically take away their funds anytime they want. So basically, the funds that are locked up are always in liquid state. So that is why it's called a liquid proof of stake. Okay, so I think we have gotten a pretty good idea about Tezos and blockchain and everything. So let's talk about writing smart contracts in Tezos. So how do we write applications on Tezos, right? So the language that we are going to use today is called SmartPy. So it is a wrapper or a package that can be used in conjunction with Python, basically. So that's why it's called SmartPy. And what it does is, it basically is a high level. So basically, SmartPy is a high level language in case of Tezos, right? So the actual language that the smart contracts are executed in is called Michelson. That is a low level code. Basically, you can think of it as a low level code. So SmartPy code is basically compiled into Michelson code, and then it's deployed on the network. So you just write you have to just write Python code, and the compiler is going to handle the rest of the low level code for you. So SmartPy is a Python library for constructing Tezos smart contract. It comes with a compiler that generates Michelson code, like I said. And the features of SmartPy is obviously, like, it's intuitive because it's Python, right? Python, as it is a very, very easy to understand language, and you can write effective code in Python and get started pretty fast, actually. You can just pick up Python in a few weeks at most. So, and if you already know Python, then getting started with SmartPy is not a challenge at all. So SmartPy, being a Python library, it's that by defining smart contracts, users benefit from the full power of Python to iterate over the data structures, call other libraries, pre-compute parameters, etc. So ultimately, the target is the Michelson language that I said. So the code that you write in the high-level SmartPy language will be then compiled to the Tezos native language, that is Michelson, basically. Okay, so some tools that we'll be using. So before we start with the actual hands-on, we need to know about some of the tools that we'll be requiring. So developing on a blockchain obviously requires the smart contract language. In our case, this is SmartPy. And we'll also need a wallet, basically. The wallet that we'll be using is called Thanos. I'll just show you in a moment. So what you can do if you are going to follow with me right now, you can open up smartpy.io/id. So this is basically a online editor for your SmartPy code, right? So something like Ethereum has its remix editor, right? So SmartPy also has its own online editor, so you don't actually have to install anything. You can start off directly on a browser, basically. If you want to learn more about SmartPy, then you can log into this website. Basically, it's kind of a interactive session, basically, interactive learning coding session, basically, where you can learn different aspects of the SmartPy language interacting through the website. So the tools that we are going to use are the coding ID, basically the SmartPy online ID, the wallet extension Thanos. Then we have some developer super packs. Basically, these are like bundles that provide us with a lot of features. Like, with tester GUI and CLI, what you can do is basically you can deploy contracts, deploy your own local network, local testnet, basically, to test the contracts, deploy them, and those things. Bundle React is like it's for the front end application, basically. So it comes with all the features like compiler and those things. You can compile your code. You can start. You already have the libraries, client-side libraries required to interact with basically the blockchain network. So all that is bundled up into a single package. Basically, you can think of it. So you can use these while you're developing. So that will decrease your development time drastically. And then we also have explorers and indexes, basically. So explorers are basically websites or tools that you can use to view the current state of the blockchain. So you can look at the transactions and the contract calls and those things. So there are two that we will be using in this session: Better Call Dev and TZKT. So Better Call Dev is mostly for contract calls. You can look at the contract storage, the contract calls that are happening, and those things. With TZKT is more of a generic blockchain explorer. You can look at all transactions and everything here. Okay, so materials. So what we are going to use today, so obviously SmartPy, we are going to use SmartPy. And then we have some client-side libraries. So these are the libraries that you can use to interact with your with the Tezos blockchain, right? So we have a Python based library, PyTezos. You can use that if you need let's say a CLI application, let's say, then you can use Python maybe. Or if you're writing a backend in Python and you require a backend, like in normal decentralized applications, you do not need it, but sometimes you might require it. So you can use PyTezos at that time. But apart from that, if you're going to use it in the front end, then we have Taquito and Consul.js. Both are pretty good libraries. You can choose any one you want. And then we have dev support, basically channels where you can ask questions, get references, and those things. You can. I'll put a link on in the channel maybe, and that link will actually have all the code and all the links that we are showing today right now. So you can go there and look at those. So yeah, join the channels. Most of the channels, like support channels, are on Telegram, so you can search them and get to them. Cool. Also, before going to the hands-on session, so in the hackathon, Tezos India is going to award 20,000 rupees for the best application, decentralized application built on Tezos. So if you're going to build, if you're interested in building one, yeah, let us know. We'll be looking into the results also. So we'll be looking into the projects. So yeah. And if you have any questions, do ping in the chat, in the Discord channel or in the chat. We'll get back to you. Okay, so let's start with the hands-on session. So first of all, you'll require the wallet. So let's get the wallet set up. So what you can do is you can go search for Thanos, and go to downloads. And then depending on your browser, you can choose whichever browser you need. So I'm on Firefox and I've already installed Thanos, so I'm not going to install it. But once you install it, you'll get some page like this. It'll ask you to import account or create new account. So you can just create a new account, give some password and good password, strong password, and then move on. So uh, here you can see there are different networks here. So the mainnet is the actual network where the actual transactions happen. So the actual cryptocurrency that has the value, like the Tez or TZ, is on the mainnet. But we also have different testnets out there. So these testnets are basically to test out different protocols, and also you can deploy your contracts out there to test how they work, right? And if there are any bugs or not, you can test them in the testnet itself. The benefit of being on testnet is that you can get free or initial tokens, basically free tokens, that free cryptocurrency that you can use for the um, contract calls and those things, right, for testing purposes. So let's get you a account. So to get an account, we'll go to import account, and then we'll have some options. We can go to faucet file, and then it'll ask us to upload a faucet file, right? So how do you get a faucet file, right? So you can click on this link, faucet.tzalpha.net. It'll open up this page, so you can just verify that you're not a bot and then get tested. So it'll give you this faucet file. You have to copy or download the file and create a JSON file and save it in your system. And once you do that, what you can do is, like, you can upload the file. So I've already saved the file, so I'm just going to import it. And once I do that, I get an account, as you can see, and here's the uh, initial funds in the testnet funds, basically, that I can use. So yeah, so the wallet is set up now. Now let's look into the application itself. So okay, so let's see what we are going to build today, right? So I've already deployed the application. Hopefully this is the, yeah. So this is the application that we are going to work on. So this is a very simple application, decentralized application that we are going to build today. But it covers all the aspects of, like a full life cycle of the development on decentralized applications. So currently, the goal of this application is, like, there's a value that is stored in the contract. So the contract state is going to be updated. So we can call different entry points. So we have an entry point called update, we have an entry point called multiply, and an add entry point. So we can call these entry points and change the value in the contract itself. So that is what we are going to do. This is what we are going to build today. And there is no backend, like a central backend to this. It's all just a single contract code and some static React JavaScript code, basically. So I'll just interact with the contract and show you how it will look. So if I go ahead and update the value, this will actually call my wallet here, the wallet extension, and I'll get this pop-up. So it asks me to do the transaction. So if I go ahead and confirm, it will basically send the transaction on my behalf. So the transaction can take some time because it's a blockchain network, right? So the transaction has to be added to a block, and then the block has to be verified, and then only the transaction will be officially included. So it's going to take some time. So till then, we can get started with the SmartPy. Okay, so it has finished already. So yeah, so as you can see, the transaction has been injected and the value has been updated. So if I refresh the page now, it should be 10 always. So even without a backend, the data is stored on the blockchain directly. So this is what we are going to build today. Okay, so let's get started. Let's open SmartPy IDE. Okay, so SmartPy ID is opened. Let's create a new one. Okay, let's create a new contract called storage. I'll just stack this. Yeah, so I think the code is visible. So let's start with the contract itself. Okay, so to write the contract, we are going to use SmartPy as it is. And the format of the code is basically like creating your own class for the contract and then creating functions or methods of that class basically. And these methods are going to be the methods of the contract itself. So to start off, we'll have to first import the SmartPy package. So once you do that, this will actually import all those SmartPy specific data types and conditions and those things. And it'll also provide us with the contract instance basically. So I can now declare a class. Let's say I'll name the class storage. You can name the class anything you want, and you have to inherit the contract provided by the SmartPy package. So by doing this, it basically identifies that SmartPy can now identify the compiler of SmartPy will identify this class as not a regular Python class, but rather a SmartPy class, as in a contract, basically. Now we can go ahead and declare the constructor. So just like normal Python classes, SmartPy also has the same feature, like you have to create a constructor. So now, and we can pass in any variable that we want. So currently our contract is just storing one value. So just one variable should be good enough. So we'll just take that value itself. And unlike so there are some differences obviously between SmartPy and Python. So in a normal class, to initiate a data member of a class, you can just write self dot stat value and then the value itself. But in SmartPy, if you want to initialize the contract state, right, you'll have to call this function. So basically self dot init. That is going to actually initialize the contract storage, and anything that you put into this this function call is going to be stored in the storage. So anything outside this call is not going to be in the storage. So that is something that you must remember. So if let's say I want to put a value called stored value, and I'm going to put the initial value as the value that I got from the constructor. So by doing this, I'm initializing the smart contracts storage to that particular with a variable called stored value, and the initial value of that is going to be value. Okay, so now let's build an entry point. Right, so let's build an entry point. So entry points are the actual functions of the smart contract. So basically, when you are going to interact with the smart contract, you're going to call some functions on it, right? So in our case, we'll have some entry points like update, multiply, add. These are all entry points, right? So these functions are going to be entry points in our class here. So to denote an entry point, what we do is like we write this as a decorator. So this is going to, okay, sorry about that. Yeah, so this is going to denote the function that we are going to write right now as the entry point of this function. So if I write, let's say, update, and then a regular Python class, Python method, basically class method, and then params. So this is basically going to be an entry point right now. So I can basically call this function on the chain and basically execute the functionality of this function. So basically we are going to update the storage with the value that we're going to pass, right? So in SmartPy, what happens is we can either write it as like this, params, and what we can do is like we can send params as a dictionary basically. So all the data that we want to send can be in this, so we can send it like this, something like this. Or we can also write the function itself as, self comma a comma b. That's also possible, but SmartPy itself will uh, compile this, like change this into this representation. So it's better to follow the representation as it is, but you can write it in any way you want basically. So to access the storage, right? So now I want to update the storage value, that is the stored value here, to the parameters that I'm going to send to this function, right? So if I want to access the storage, I can do it by calling it like serve.data dot the value of the name of the parameter basically that I want to update. Then params. So what basically this does is it is going to access the stored value that is in the storage of the contract, right? And it's going to update it with this value that is being sent over from the parameters. You can name anything, like name it as anything you want. I'm going to use value for the purpose of the demonstration, but you can use any variable name you want in this case. Okay, so we have the first entry point, and this is just going to update the contract storage. Let's create a few more entry points for the other functions. We have another function for multiply. Let's create that. Okay, so stored value. So for multiplication, SmartPy has its own set of data types and uh, operations that you can perform on the data types, right? So for that, we can go to the reference smartpy.io/reference. Basically, this is going to give you the list of all basically the data. There's a doc for the SmartPy itself, so you can follow that. And here we can find all the data types that are there. So if I go here, you can find we have booleans, bytes, and then there are specific functions that you can perform specifically with SmartPy in this case. sp.pack, unpack, these functions are specific to these SmartPy data types. But we also have some similar data types with Python, right? So let's say integer, right? Integer is a common data type, and that we're going to use right now. So integer has all these different values, right? Like all these operations, arithmetic operations, and these are very similar to the ones that we do in Python. So basically what we can do is, if we want to find the just to multiply a number, what we can do is just do this, and SmartPy will automatically evaluate it and multiply the storage value and the value that you've passed, and it update the value also. So that is possible just because it's Python. And let's get for this one also add. So in add, we have two parameters here. So we are going to pass two values. So let's say we have a value called A and a value called B. And obviously we'll have to put a plus here. So what we're going to do here is like we're going to add all the three numbers, like the storage value and the two values that are passed in the parameter. So we are accessing the parameter values like this. So we passed a parameter called A and a parameter called B basically, and we are going to access that. Right. So that way, I think we have completed the smart contract. So there is nothing more that we need to write for at least this application here. So we just wrote a few methods and we are done basically with the backend, complete backend. We can, if you want, we can run the code and see. So it's going to compile it and it's going to check if there are any errors or not. And if there are any errors, it's going to throw an error warning basically. So yeah, so in case of like writing smart contracts, right? So if you write smart contracts, then it is suggested that you write test cases for it. And SmartPy test cases as in like testing the smart contract itself, right? Because the problem with smart contracts is that once you deploy it, the data is immutable in the blockchain. So you cannot update the contract code. So if there's a bug in the contract, then it's going to always be there in the contract itself. So So it's always good to test your contract properly and write test cases for it. So SmartPy is throwing this error because I have not written any test cases. So we'll just go ahead and add the test cases. So I've already written some test cases for this. I'm just going to paste it here just to be fast here. Okay, so the test cases are like this. So basically, to initialize a SmartPy test, you have to use this decorator. Basically, this is going to let SmartPy know that this is a test. So once we do that, we can write the test function. And the test function, it is basically like initializing the class and then calling the functions of the class and validating the values of the class, like the data that is in the storage, right? That is all that you have to do in this case. So what we're doing here is we create an instance of the storage class with the initial value of 12. So basically, we're initializing the stored value as 12 in this case, and we are then creating a scenario. So basically, scenario uh, is required by the SmartPy to to evaluate your transactions. But basically, each of the calls that are going to do is going to simulate the transactions, and it's going to add it to the scenario itself. So we have to create a scenario, and then we can set some give some styling to it, like a header or something like that. That's also possible. But the main thing is like to add the contract. So we have to add the contract to the scenario. So this is all available in the reference, by the way. So if you go to test cases and test scenarios, you'll find the whole thing, all the things. Like there are a lot of things that you can do with SmartPy that I'm skipping here, but you can take a look at the reference and you'll get a lot more details. So basically, what I'll do is I'll just add the contract to the scenario. So that way, the SmartPy compiler is like the emulation knows that there's a contract and that contract is going to be called. So now every time I do a contract call, I just add it similarly to the scenario, and the transaction is executed, and it's going to be it'll be represented here soon. So we can do that, and basically that's what I'm doing here. So I'm calling the function, sending the value. So this is a parameter name that I used here, if you remember, param set value. So value equals to 15, and I'm just doing that transaction here, adding it to the scenario. Then this is something that SmartPy provides. Like you can show other values also besides normal uh, smart contract or smart contract storage calls, basically. So you can do something like this. So this is going to help you in testing in complex smart contracts. You can do these things and log the data, and you can see what the current storage value is or something like that. You can do that. So yeah. So moving on, then we call the update function again and set the value to 25, and we're multiplying it with 2. So the value, current storage value, should be 50 right now, right? So to validate the thing, right, whether the storage has updated properly or not, the smart contract is functioning properly or not, we can use something called scenario.verify. So that is going to actually verify whether the value that is stored. So I'm accessing the contract, that is C1, the instance of the contract, and the storage data, that is data.stored value, and I'm ensuring that the value is equal to 50 and not something else. So I'm doing the same thing here. I'm going to add, and then I'm going to verify the value. So it's 39. So if I run this right now, if there are no errors, it'll give me a whole list of things. So basically, now we have the actual contract here. So the contract code is shown here, and then the transaction. So I called an update call. The value was this. The storage was updated to this. Similarly, for the other ones are also shown here. So if I, let's say, do some mistake here, right, the value doesn't match, then it'll throw me an error. So yeah, so we get an error. So verification failed. So it'll just throw an error like that. And that's how you do testing on SmartPy. SmartPy makes it very easy to write the test cases, as you can just write it with the code itself and run the test cases directly here. Okay, so now that we have written the code and tested it properly, we shall deploy it, right? So there are many ways we can deploy it. You can click on the deploy here and then use SmartPy deploy features if you want. So it'll provide you with this, and you'll choose the different settings like the network, the wallet, select the wallet and connect with it, and you can deploy it. But I personally do not prefer this because like I like to customize and if you want to automate it, like let's say if you want to automate the thing, then this is not the best way of doing it. What I do is like I have created my own script. So I have the script. So this deployment file is basically the script that can deploy the contract for me. So in this file, basically I'm using a Tezos client, like I said, and the libraries. So this Tezos client provides pretty simple functions that will help you actually deploy the whole code. And there's a configuration here. So the configuration requires your private key and the public address and RPC network and those things. So you can get all these data from the wallet. So the private key can be found in a wallet. I'll just show you how you can get it. To get the private key, what you can do is you can just click here, go to settings, and then reveal private key. Basically, it'll ask you the password that you have used at the beginning while you are initializing the extension. But once you provide the password, you'll get the private key. So once you have the private key, what you can do is you'll need the RPC. So RPC is basically RPC node that is actually connected to the network, the blockchain network. So you can use this node to actually either query the blockchain or send transaction to the blockchain. So that is what RPC is. And then the main contract code. So this is a Michelson compiled code. This is not the SmartPy code, basically. So this is the compiled code that you get from SmartPy. So if I go to deploy Michelson contract and then code.json, that is basically the whole code, the Michelson compiled code. And similarly, we have storage.json, that is the storage. So we are going to use both of them here. So the contract and the storage. So you can put them, you can change the value here. So that way you can update it to anything you want. So currently it's set to 0, let's say. And what you can do is you can just deploy the code and deploy the contract. So the contract code, like deployment code itself, is not that important, as you can look at the documentation for Taquito. You'll get all these functions that I'm using. I'm just using a function called originate to originate the contract, basically deploy the contract. I'm sending the contract storage and the code and just waiting for the contract to be deployed. So let's just do it and test it if it works. So I'm just going to run the code. So node.deploy, and we should see some cool. Yeah, so we can see that it is waiting for confirmation on the origination. So basically, this is the contract address that we are going to use. You can find this in the blockchain explorer also, but it's much easier to just take it from here. And besides the contract address, we also get the entry points and the order of the parameters that we're going to pass. So here we have the update, multiply, and add functionality. And the parameters, the update function just takes an input integer value, and multiply also takes a single integer value. But the add has 2 values, so it will tell you the parameter ordering, basically. So you have to pass the parameter A first and B second. This will come in handy when you're going to actually call the contract, basically. So now let's go on to the client code, that is the actual front end. So I've already written the code here. So it is just the basic, this structure currently is just the basic create React app boilerplate. I have just added some forms and fields and handle functions, basically. Nothing that fancy in this thing. So what it does is basically how you're going to do it is basically you have to initialize the client, basically the client application as the client library. So we are using Taquito in this case. So we have a state variable that stores a client instance, basically the Taquito instance, and we have some other important state variables called the value. So this value is the actual state of the contract. So I can store the value of the state and just update in this one. That is all it is. And what I'm doing here is basically I'm initializing the client and then just getting the storage value and waiting for the user to do some operation here. So when the user does some operation, I'm calling a handler function and then just calling a function like add and multiply and these things, right? So this part is mostly standard React code. The main part where the actual interaction with the blockchain happens and the initialization of the blockchain client, basically the Taquito client, here is in this library section. So in the library, we have config.json. This is basically how I've structured the code here, but you can structure it differently if you want. You can use your own structure method, or you can use the React bundle also that has a pretty good predefined structure. You can use that if you want. So both works. In this case, I've created my own structure here. So basically, I'm using this config.json to put the values of the application, that is the name of the decentralized application that I'm building, that is storage example, let's say. The network that I'm going to deploy it on, as I said, we are using the testnet called DelphiNet. So there are different testnets that you can use, like Edonet or something like that. But right now I'm going to deploy it on, like I've deployed the contract on DelphiNet. So I'm going to use this. Then you obviously need the RPC again to interact, basically. So I'm using the same RPC link that I had used, and then the contract address that you want to interact with. So I'll just, this was an old contract address, so I just put my new contract address here. So I've updated the contract here. So now moving on to the connect file. So basically, this is where you're going to initialize your client and connect the wallet, basically. So setup is just creating an instance of the Taquito file, basically a Taquito library, and storing it in this Tezos variable and sending it back, basically. And this one, the connect wallet, is basically creating an instance of the wallet that is basically connecting to the wallet and providing you the instance so that you can connect that instance to the actual Tezos client. So usually what you'll do is like you'll directly do it in the setup, like do this and then add it here directly to the Tezos basically client. The documentation provides a very good like example code basis. So if I go to Taquito, just to show you Taquito docs, let's say, hopefully, yeah. So I can go to docs here and then you can just search. So I'm using the wallet API currently. So you can get the code examples that you need and those things right from here. So you can use this. So basically, usually you create the wallet and you connect the wallet directly at the same time. But I did it differently so that others can use it also. So basically, in this case, we are doing it separately, but you can do it in a single go also. So the second one is the interact one. This is the main functionality of the whole contract, like the contract as in the application, basically. So here, what I'm doing is I'm interacting with the contract. I'm calling the functions. So I'm using the Taquito client again. Tezos is the Taquito client, and I'm calling the wallet API in this case. And basically, I'm asking the wallet API to give me an instance of the contract. So I'm saying wallet.add contract, that is the contract address. And what Taquito does is provides me a contract instance of that thing. So I have the instance now. What I can do is like I can call different functions on it or retrieve the storage of the contract and do those things, right? So in this case, I'm calling the function. So contract.method.update. So I'm calling the update entry point or function on the contract, and I'm sending the value and then just sending to it, and then just waiting for the confirmation, and that's all on this part. And similarly for multiply, I'm doing the same thing, getting the contract instance, calling the multiply function, passing the value, and then waiting for the transaction to verify and successfully apply, basically. And for the add, I'm taking two parameters, A and B, and I'm going to send it in this order that I found in this one, the entry points list. So I have to pass A first and B second. So I'm passing A first and B second, and just sending the contract call again and waiting for the confirmation, basically. Yeah, so that's mostly the part for the contract calls. But to retrieve the data from the contract, right? So now you have called the contract, you have updated the contract storage, and have done all those things, right? But now you want to actually retrieve the data back. So how to do that, right? To do that, you have to directly read the storage. So what I'm going to do here is like I'm going to get the contract instance, and then I'm going to get the storage of the contract, basically. And the storage itself will have the data that you are going to read, right? So right now, there's only one single variable that is being stored. So I can just do storage.toString. But if there are multiple items in the storage, then I have to select the one that I want to read particularly. So yeah, so that was the whole code for the application, and we can even try and run it. Okay, so yeah, so once we run it, we can see it work. So I've already deployed the application on this link. So if you are following with me, you can actually install your wallet, get your testnet account, and actually interact with it directly without actually having to run or deploy the contracts or anything. You can try it and test it out if you want. But I'll show you how to do it on locally also. So I can open up localhost 1000, and that will open up my local systems. So as you can see, I set the storage to 0, so it's currently 0. And now I can send an update. Let's say I want to update the value. So I can do that. And the wallet is going to pop up. I can confirm the transaction, and the whole transaction will go through basically. So it will take some time, obviously, again. And once it's confirmed, it will show up here. And similarly, you can do the multiply and the add also in the same fashion, basically. Okay, so I think we have covered most of it. If there are any questions, we went a little fast in the this part, like the application part. So I'll leave the links to the documentations so that you can get a look at the different client libraries and you know the different functionalities that they provide. And I'll share the link in the Discord channel maybe. So that will be where you can get the link. And also I'll share the code for all this, the front end and the contract code and also the deployment code, so that you can use it if you want, and you can modify it also if you want, and use it according to your need. So yeah, so we have the current storage updated to 10. Let's do one more. And so let's say I want to do this. So this is going to add 20 to the storage. So contract call, confirm the call. Cool. It's gonna take some time again. Hopefully it'll be done. Okay, so while I'm waiting for this to finish, why should you build on Tezos, right? Like there are so many blockchain platforms, and why choose Tezos to build on, right? So Tezos is relatively a new platform and has a very good community support, and also good technology. Basically, the self amendment features, the self governance, the liquid proof of stake, and the formal verification, and a lot of things are there about Tezos that makes it a lot superior in my opinion. And as the as a state of the as the network itself is in a very you know young stage, so there are very less projects right now on the network itself. So you can jump in and you can build projects on top of this system, right? And contribute to the ecosystem, and at the same time building good projects will can also help you. So the people who started with Ethereum, right, at the very beginning, they have built awesome projects, and they are pretty good at it right now. So if you start now, you can be a very crucial part of the community and the ecosystem also. So yeah, I think that's one good reason why you should try out Tezos and try to contribute to it. So yeah, so the storage worked, as you can see. So I guess we can conclude here. I'm gonna call. Yeah, Trithak is here.
Yeah,
Yeah.
it was really an amazing one. You know, it was good to see the talks. Along with that, you showed us how exactly it works. Everything was very fantastic. Uh, just we will go through some of the questions if you wish, or
Yeah, yeah,
you
awesome,
want to
awesome. Yeah.
continue in the Discord one.
We can take up if there are any questions right now. We can surely take it up.
So yeah, What SHA do you prefer? What SHA? Sorry. Yeah.
What SHA?
SHA? What is this? I even don't know.
Can you just maybe share your screen or something? Like paste the chat in the chat maybe. I did not get
Yeah.
your question.
Anant, can you clarify a question if I am uh, wrong somewhere? Please do that. Move on to the next question till then. How WhatsApp uses blockchain?
Uh, I don't think WhatsApp uses blockchain.
Yeah, I even don't know. And where it
I think
uses.
blockchain WhatsApp is very much centralized. It is end-to-end encrypted, but it does not use blockchain at all. Okay, so okay, I got the question. So what SHA do you prefer? So I by
Okay.
SHA I mean you mean the SHA hash. So I think SHA 256 is good, but 512 is better. I think so. Hopefully that is the question that you're asking. You can clarify maybe in the chat again. Yeah.
Right. So, what is mining in blockchain and does it generates any cryptocurrency?
Absolutely, absolutely. So some networks like Bitcoin and Ethereum 1.0 support like has the proof of work that is the process of mining basically. So the miners who are mining these blocks, right, who are creating these blocks, get rewarded for their work that have done, right. So these rewards are mostly in a declining fashion. Like Ethereum has a declining, like the value, the reward that you gets half every after every I don't remember the exact number of blocks, but after every specific number of blocks the reward will get half. So that's how they maintain the flow, like the volume of cryptocurrency that is out in the market. And one day it'll cease to exist. So basically cease to exist, and the reward will cease to exist. So basically mining will not give you rewards, but in most networks I think currently all of them are still providing the rewards for the mining.
Right. So, I hope one of you got your answer. Marmik, how mining works from business to blockchain.
Business to blockchain.
So,
I don't think I got the question. If you
okay.
want to know about mining itself, I can talk about that. So mining is so basically mining is specific to proof of work, that as I suggested, right. So when there's a problem, right, when there's a miner who wants to create a block, basically create a block for the blockchain. What they'll do is basically they'll take some transactions and they'll put it into a block, and then they're going to solve a cryptographic puzzle. So this puzzle uh, is may vary from network to like blockchain to blockchain. So Bitcoin has a different maybe, and Ethereum has a different one. So usually it is basically like the nonce. So a number of zeros at the end of the number or something like that, hash. So basically what they do is like they hash the data that is being stored in the blockchain, and then they have some counters and then timestamp and those things, they all hash it all together, and then they create a hash. And the puzzle can be like, let's say the hash that is generated has to have five zeros at the end or something like that, right. So the puzzle has to be solved in a way like you have to create a hash, like select transactions and select other parameters like the timestamp and the counter. Basically you have to select them in such a fashion that the hash that is generated has these exact five number of zeros or something like that. So that is a cryptographic problem. That's a very simplified version of it, but that's how mostly it works. So yeah.
Uh, why would people use virtual currency?
Very good question. So, if you heard my what I was saying, talking about decentralization, right? So, currently in the physical world, what happens is you have some money. Let's say you have $10, let's say, right, and you are going to send it to someone else, right? And that person can be at the other end of the world, right? Completely other end of the world. So what happens is there's a different currency there. So there's going to be a conversion rate, and there's going to be transaction fees, right? So the banks in between, right? So if there's a single bank, then the bank will take up some transaction fee in between. But mostly it's like two banks or something like that. So each bank will take up their own transaction fees or something like that can happen, right? And then the exchange rate that I talked about, and also at the same time the delay between the transaction, right? So usually it takes up to 2 hours, 3 hours, 4 hours, maybe even longer, right, for these kind of like exchange currency kind of thing situations, right? Mostly. But nowadays the situation is much better, but still, like, the delay is there. But in case of Bitcoin, like cryptocurrency specifically, by virtual currency, I believe you're talking about cryptocurrencies. So in cryptocurrency, what happens is you don't have these limitations, right? You don't have a middleman in between. You just send a transaction, and the transaction goes to the network, and it reaches the person that you want directly, peer to peer, right? So there is no middleman. The speed is much faster compared to the normal physical transactions like these that I talked about. And yeah, the fees that are required is also much less.
Right. So I hope, Mamik, you got the answer. Heth Suthar has asked, any criteria to adopt blockchain for business?
Any criteria, right? So by criteria you mean requirements, or like can you
Maybe
clarify
I
on that?
rules, or yeah, maybe something like that. Heth, can you clarify the same? Till then, let me tell my audience that if you build any project using Tezos at our hackathon, that is the Python week, which is starting from tomorrow, that is 8th of January, and it will be for 48 hours. If you build something using Tezos, there is a prize money of 20,000 rupees, Indian rupees. I think Shom has already described this, right?
Yeah, so basically, if you build a project that is that impacts the ecosystem in a positive way,
Yeah.
then surely we are very interested. We'll surely be interested in rewarding you the prize. Absolutely.
Right. So yes, Heth is saying that any rules or something to adopt blockchain for businesses.
Okay, yeah. So for businesses, like, let's say, so I did not talk about this in the talk itself. So blockchains can be of different types, right? So there is something called public blockchain and a private blockchain, and there's something called a hybrid blockchain also. But let's not go there. So public and private, right? So public blockchains are these blockchains like Ethereum, Bitcoin, Tezos. These are public blockchains. Anyone can participate in it. Whereas private blockchains are blockchain networks where you have to have permission to actually get into the network, to access the network and do things on it, right? So businesses mostly, like corporate businesses, mostly use private blockchains, and these blockchains are not actually related with cryptocurrency, like I talked about, right? So blockchains like Hyperledger, right? These things do not have cryptocurrency in it, but they do have decentralized application, features to build these decentralized applications, right? So businesses are going to mostly use these kind of blockchains. And yeah, for any rules specifically, I don't think rules as in, I don't think there are any specific rules. But yeah, if there's a requirement, like, if there's an actual requirement for a blockchain, right? Immutability, or like data is being shared between multiple parties, then you can do it through blockchain. You can have some escrows, like I talked about, right? So if there's a transaction happening between two businesses, right? So you can have this automated smart contract sitting there, right? And the funds are already escrowed into it. Escrow is like, the funds are locked, right? And there can be a time lock on it, so the payment will happen automatically. So you don't actually have to go and pay it, or there won't be any discrepancy, right? Like a business cannot deny the payment because it's already locked in, and you can just access the contract and get the funds, right? So these things can be like, depending on the requirement, there are a lot of use cases for blockchain on in businesses. Absolutely. Some use cases include supply chain, order tracking, and a lot of these are being done and being researched even right now.
Right. Great answer, Shomu. Even I was not knowing about all of these things. Thank you very much for the talk. And I would like to ask one thing, that
Sure.
you have given a great talk on these all of this stuff, but still, is there anything specific which you want to share with our hackers during the hackathon, which they should do, follow, or something like that, so that they can uh, be specific with what they are going to do with Tezos or the decentralized applications or anything?
Okay. So if you're planning to work on Tezos, right, or a blockchain application, decentralized application, then I'd suggest you to look at the current trends, right? What is trending right now? Basically, what applications are actually being used. So basically, the idea of building application on blockchain is to get normal users, right? Like normal users, like anyone else, right? Get them onboarded to blockchain and cryptocurrency and this field, right? Because yeah, it's a different field. People usually don't are not that aware of this blockchain technology, and there are very few applications, publicly available applications that people use extensively, right? Like compared to other centralized applications like Facebook, Twitter, and other Amazon and Flipkart, these things, right? So blockchain applications are much less used, but their application, like the features they provide, are pretty good. In my opinion, it's awesome. So if you can build something that attracts the normal users into the blockchain ecosystem, that will be very good. And besides that, also there are projects that you can look into, like the DeFi projects, um, then collectible projects that I was talking about, NFTs and those things. If you can work on those, that will be very good. It will impact the ecosystem and the community as a whole, and in a good way. So yeah, those are the things that you should look forward to.
Great. I hope hackers find something out of their talk and everything. Yeah, Anant has wrote something here that Karnataka government is developing a system based on blockchain technology for online property documentation. Is this going to be a new normal?
I see. I am very bullish about blockchain. So, like, I think blockchain is going to be the future. So, like, a lot of countries are like Russia is thinking of shifting to cryptocurrency. So, there's a lot of development going on in blockchain, and it's still a nascent. Like, the technology itself was developed a long time back, but the implementations and the features that are being developed right now is in rapid growth. So I think blockchain is going to be the future, and a lot of things are going to move to blockchain sooner or later. So yeah, you can onboard us right now, or you can onboard us later. But I think we'll all be on blockchain sometime soon. Yeah,
Promotion is on the way, Anant. So you start using blockchain right away.
right.
Yeah.
Yeah,
This was an amazing one, Shoma, and we are, really glad to have you here. Thank you very much for being with us and showing us how it works, your projects, and everything. Thanks a lot.
yeah. Thank you so much. Thank you, Tritok, and thank you, the Python Week and Masava. So it was a awesome experience. Thank you for giving me the stage. Yeah, and I hope to be here again. So yeah, see you soon.
Pleasures. Hi guys. So we will share the feedback form in the chat section. Along with that, it will be visible on the screen here. So do fill it out. Don't forget to fill it within 15 minutes. That is, as it will be open just for 15 minutes and won't be reopened again. This link will be used as a feedback form. Along with that, your details will be used to assign you the certificates. Thanks a lot for joining in today. Just within 5 or 10 minutes, we'll be coming up again on this channel for the fun times. That is a filler session by the Python Week. Make sure to join this. We are going to have something fun. I don't know about it. So again, keep an eye on the social media for the next sessions. Don't forget to subscribe the channel so that you can get the updates for all the workshops coming ahead. Stay tuned and don't forget to join in the filler session along with that the next session which we are going to have today. Hope to see you there and stay safe. Take care. Thank you.